Good morning, ladies and gentlemen. To start off my class today, my question for you is, how do you measure mass on the International Space Station?
You just stand on some scales, don't you?
Aren't they floating up there? The International Space Station.
Wait a minute, is that Tommy Hamilton?
It totally looks like it, right? So I'm thinking of Libby. I had Libby in
Okay,
class.
it's one of those Hamiltons.
Yeah. International Space Station. What do they even do up there? Well, science. They gotta work out, right? Well, they can't walk though. So how do they stay in shape? How do you measure the mass up there? Okay, moving on. Okay, my challenge for today. What is the relationship between the number of washers attached to the blade and the time for 10 cycles?
Miss Moore, that sounds so random. What's going on here?
Let's take a look. So over here, I have a hacksaw blade screwed into the block and attached to my table. And what we're gonna do is we are going to attach the washers at the end here, and we are going to count 10 cycles. I want you guys to make your notebooks look like this. Pause the video. This is where we're going to be recording our data table clearly. Number of washers here, the time for 10 cycles. Why 10?
It's because it happens fast.
Yeah, what if I said for 1? What? Oh,
It's going to be hard.
yeah, and then notice how it kind of fizzles out there.
Yeah.
So we get a better number after 10 cycles. So, and then that last column, just wait on it.
And they're going to be
Oh, too soon, too soon.
9 trials. So you need 9 trials.
Yeah, 9 trials. Okay. Let me go ahead and just write 9. 1, 2, 3, 4, 8, 9. Okay. Boom. Just so I don't get my data messed up here. Okay. All right. Step 1. Put said washers.
You're going to need that little guy.
Oh, this guy goes on this side, huh?
Otherwise, it'll fall off.
Wasn't there a second one? Oh, there he is. Right here, like this, right?
Yeah.
And then
Then a big
and then
washer.
this one.
No, big washer.
There we go. It's rocket
Little
science.
washer.
It's like a small washer sandwich.
There you go. While you're doing that, I'm going to get a stopwatch.
Oh yeah, I need that. The athleticism involved in this is out of control. Okay. Okay, here we go. All that for 2 measly washers. All right, Boykin, are you gonna do us the honors? With the timing?
All right.
You ready?
Go. Oh, gotta start all over again. No. You can let it go.
That was a pathetic thing, anyways. Ready?
What I'm doing is I'm watching the phone, not the. So go.
Okay.
1, 2. Okay, I got 4.30 seconds. But let me just stop.
All right, so we made a few changes here. Miss Moore realized that she didn't want it to be number of trials, it's number of washers. So make sure 2, 4, 6, 8, all the way to 18. And then we decided to do the first trial over again. It was our first trial, so we want to make sure we start off with a bang. Change that number to 3.51. All right.
Okay.
So now we have 4 washers on here. Before we had 2, now we have 4. And here we go. You ready, Boyden?
We're ready. 2, 3, 4, 5, 6, 7, 8, 9, 10.
What you got?
I got 4.63.
4.6 washers and go.
Whoa, that's slower.
Ah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What you got?
I got. Oh, it didn't stop. I hit the wrong button. Let's try that again. And 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Boom.
5.38. Now,
We are on 8 washers. Ready, set. Boom.
damn, I'm hitting it and it's not stopping. That's okay. We'll do it again.
You got it?
Go. 1, 2, 3, 4, 5, 6, 8, 9, 10. Oh, it was 5. Oh, no, I pushed it and it did not stop. This time for sure. On your mark, get set, go. 1, 2, 3, 4, 5, 6, 8, 9, 10. 4.99. That can't be right. No. Stop.
And ready?
When you are.
And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5.41. We are on 12, 12, 12. Ready, set, and go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6.02.
It looks like it's going slower to me.
Yeah.
It's easier to.
On number 14.
14 washers.
All right, here we go. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6.32. Dang, it's getting slow.
Now, Ms. Mo.
16.
16!
Okay, ready, set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. I almost messed up my counting there, but I caught myself.
How many?
18. This is our last trial. And ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our thing is getting sadder. It's moving down. All right, 6.78 seconds. The trial was 6 washers. And ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4.50. That's more like it.
I think we should do 4.
Oh.
What are we gonna do again?
We are gonna redo the trial with 4 washers. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4.06. Nailed it.
What are we doing again?
This is our first trial with 2 washers on it. And I'm nervous. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3.35.
Huh.
I know.
Okay, such is life.
Let's make a graph to show the relationship between the number of washers. Hey, look at that again, the clock, and the time it took us to for the washers to make 10 cycles.
Okay.
Little note though, we're actually going to graph the time it takes for 1 cycle. So what we're going to do is we're going to take this decimal and we're actually going to be moving it over 1 spot when we graph our
So
data.
instead of 3.35, it's going to be.
0.335.
That's easy.
Yeah, so we're gonna keep it in portrait mode here. I'm just gonna I'm gonna do a sketch first so we can get our data here real quick.
All right.
So x-axis is gonna be number of washers. Y-axis is time. And then let me go ahead and get my little cheat sheet up here. So to help us choose the proper scale, first we need to find the range of data. Well, Ms. Moore is ahead of the game, and she's going to tell you right now that there's 23 spaces on the bottom right here. And then this way, we're working with 35.
Yeah.
So once I've counted the spaces, it says divide the range by the spaces. Okay, so for our x-axis, we're going all the way up to 18. So I'm going to say 18 divided by 23. When I do that, 18 divided by 23, I get almost 0.1. Oh, sorry. I get 0.7, which is almost 1.
So you have to round up to the next good number, which would be.
1.
All right.
So that means that each space is going to be 1. Makes sense. We've got 18 points, 23 spaces. It works out. How about this top one? Well, we're going from 3.35 all the way to 6.78.
So what is that range of data? Oh, okay.
So I gotta do some math here first.
Oh my, she's
Oh my
subtracting!
7, 8 minus 3.35, and I get 3.43. Okay, this is my range of data. So, and don't forget, when we graph it, we'll move it over, but we just need to know what the range is here. So I take this number, and it says to divide the range by the spaces. Here's the range. I'm going to divide it by the spaces. 3.43 divided by 35. And I get, almost 0.1 this time. So,
Except we're going to have to move the decimal over,
yeah.
aren't we? So that's going to be 0.01.
Yeah, 0.1. Then we're going to move it over, so it's going to be 0.01. Okay. All right, so let's go ahead and take a look at what this means over here. So now we can go ahead. I'm just going to draw my line on the bottom here.
Okay. Yeah. No, you're good.
And then I'm just gonna, I don't really know how far I'm gonna go up here, but I'm just gonna go high enough.
So with the washers, you can start from 0, but the time you can't.
Yeah, so we're gonna start from 0 here. In fact, let me go ahead and label what I've got going on. You can't see that. So, again, we're talking about number of washers here. Can y'all see that?
I can.
Okay, good. And then time over here. Seconds. Okay, so I'm just gonna go ahead and number. Here we go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
You're a harder worker than I am this morning. I would have done 2, 4, 6, 8. But hey, whatever floats your boat.
Hey. Okay, so for this side over here, now we have to count. Well, first of all, we don't have to start by 0. We don't have to start at 0. We're actually going to start at point. Let me get my little. We're going to start at. Move that over here. 0.335. Actually, 0.3. Let's start at 0.330.
Okay.
So this spot right here is going to be 0.33.
And then each line is going to be
0.01.
So the next line would be 0.34, wouldn't it? 0.34?
Yes, 0.34.
You're not going to write all those, are you?
No, I'm not.
All right.
Okay, so 0.34, 0.35, 0.3. Did I do that right?
Yeah.
0.34, 0.35, 0.36, 0.37, 0.38, 0.39, 0.40. Doesn't it look good to you?
Looks great.
0.41, 0.42, 0.43, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's gonna be 0.50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.60. And we'll go 1, 2, 3, 4, 5, 6, 7. Oh, 1, 2, 3, 4. We'll go. Uh-oh, I'll need a little more
You got to
space
go
here.
up to
Yeah, a little
0.67.
more love. Okay. 1, 2, 3, 4, 5, 6, 7, 8. We'll go 0.68. That'll work, right?
Yep.
Sweet.
Now you have to plot the data points. Should the boys and girls do it themselves?
Do it now.
I'm going to stop this. Go.
Is your graph linear? Well, here's what I got. I should look a little bit down that angle there.
That is not a straight line.
No, definitely not a straight line. And so, why is this? Well, let's go ahead. There we go. And to solve this problem, we're going to actually graph the time as time squared versus numbers of washers. So,
Okay.
let's go ahead and do this. In your data table over here, we're going to take this number and we are going to square it. And I'm gonna square the decimal version of it. I'm gonna when we moved it over. So I'm gonna say, go ahead and well, actually, pause the video. Do it. Okay, so we're having some slight technical difficulties, but hey, what would life be without some challenges? And so I actually did all the work, so I'm gonna explain what I did. We have some new data over here, and so I just did the same math. The bottom is still gonna be the same. We're still gonna have 18 washers right here. But then for the side, I had a new data range, 0.46 minus 0.112, so I did that math, got this, and then I just divided by 35, and again I get 0.01, which means that we get to count by 0.01 again, like yes. Woo-hoo! So, but we start with 0.11 right here, and then I just count up, so 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, 0.2, and then from there I just count by 10, 10, all the way to 0.46.
So they should make their graph like that.
Make your graph, and then you're gonna graph my data points. Do it. Is this graph relationship linear? Well, let's take a look. Oh, that's actually a really good angle there. Yeah, so looking down this line, you can definitely tell that it's significantly more linear. So what does this mean? What are we gonna do with this? Well, the next thing we're gonna do is we're gonna collect some data for the standard mass.
Standard mass?
So I've got this. So I've got these masses right here, and these are standardized, and this one is 50. You can see it says 50 on it. We want the 20 gram one. Let's see. Here we go. It's this one. Oh, yeah.
It says 20 grams on it.
Yeah, that's okay. So we are gonna put it. Oh,
I've already got one on there.
We are prepared. Okay, so we got a 20 gram mass on here, and again, we are going to collect some data. Let me grab my whiteboard for the time that it takes the 20 gram mass to do its thing. Okay, so let's write that down. And here we go. Let me turn it on. Let me reset it. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 4.81 seconds.
So 21 seconds. So how much time for one?
So how much time for one?
How much time for one cycle?
Oh, for one cycle, okay. So this was for 10, so we can just divide that by 10, so 0.481 seconds for one cycle. This was for 10, for one cycle.
For 20 grams.
For 20 grams, okay.
Okay, go.
So collect data for the standard mass. I'm gonna go ahead and write that information up here. Actually, I'm gonna put it over here. So this is for my 20 gram mass, okay? So my total time for 10 seconds was 0.481 seconds. It was this. So my time for just 1 second of the 20 gram mass is gonna be 0.481 seconds. Okay, I just moved that decimal over 1. Let's see.
Then what
else
do
do I have on here?
You gotta square it, don't you?
I do. I'm gonna go ahead and write an equation on the board. We want our time to be squared, right? Because that's what we did before. So we know that the 20 gram mass, we know that the time, if I square this, the number that I get, plug it into your calculator, see if you get the same thing, is 0.231 seconds squared, right? Square that number, square this, I get this number. Okay, so for my 20 gram mass, this is how much time it took me when I squared it. Now, I want to kind of go back to the graph that we did before. I want to take a look at this graph right here.
Okay.
So it says, what is the slope of your line? Now, in order to find the slope, I would do rise over run. So let's go ahead and do that. So this is back to my other stuff over here. So the slope of my line, so slope equals the rise over the run. And my rise, my y-axis was time squared. and I divide it by my run, which is just number of washers. And one thing I added on here, which is I put a little squared right there. Okay, so can we do this? Can we do this calculation?
Let's do this.
Let's do this. Okay, so the change in my time. Oh, gotta look at my thing over there actually. My notes here. So let's go ahead and choose 2 data points. So I'm going to use my data point right here at the very end. That was at 14 seconds, and I'm going to use my 2-second one. So at 14 seconds, we'll go right here. At 14 seconds, my time was 0.399 seconds. Right there. I'm going to subtract that from my time with 2 washers. Oh, sorry, not 14 seconds. Sorry, 14 washers. And at 2 washers, I've got 0.112 seconds. I divide this by my number of washers, 16 and 2. Okay, I'm gonna plug this into my calculator. 0.399 minus 0.112 gives me that, and I divide that by 14, and I get 0.021, we'll call it. 0.021 seconds, and this was washers. Seconds divided by
And I think that's second squared per
washers.
washer.
Oh, you are totally right. Second squared right there. Okay, so here's my slope here. So let's go ahead and write this in another way. So my slope is 0.021 seconds squared, and this is the same thing as saying equals 1 washer. Okay, and over here I've got this equation, 20 grams equals 0.231 seconds squared. So my question for you guys is, how can we use the equations that we have here to find the mass of just 1 washer? Pause the video. You've got this equation right here. You've got this equation right here. Figure it out.
Get a good look. What is the mass of 1 washer? Sweet.